we are told a specific story about the digital age. We are told that the binary code, the language of zeros and ones that powers every smartphone, satellite, and AI model on Earth, was a purely European invention. A stroke of genius from the likes of Leibniz and Boole in the 17th and 19th centuries. But what if that story is incomplete? What if the fundamental logic of the computer age wasn't born in a sterile lab in Germany or a garage in California, but in the sands of West Africa, centuries before the first light bulb was ever turned on? This isn't just a visual coincidence. This is mathematical proof. Today, we are going to reverse engineer history. We are going to look at a forbidden technology called Bamana sand divination. We will prove that ancient African priests were not just mystics. They were computer scientists running recursive algorithms without electricity. And by the end of this video, you will see why the blueprint for artificial intelligence has been hiding in plain sight for 500 years. Welcome to the genius of Africa. To understand this technology, we have to stop looking at African rituals as magic and start looking at them as engineering. Let's look at the Bamana people of West Africa. When a Bamana priest, known as a diviner, sets out to predict the future, he begins a process that looks random to the untrained eye. He draws unpredictable dashes in the sand. But watch closely. He isn't just drawing. He is calculating. The process is strict. He draws 4 sets of random dashes. Then, he counts them. If the number of dashes is odd, he marks a single vertical line. If the number is even, he marks 2 lines. Does this sound familiar? It should. This is a binary system. On or off. Odd or even. 1 or 0. By stacking these results 4 times, the priest creates a symbol. In computer science, we would call this a 4-bit word. But here is where it stops being just a recording method and becomes an actual computer. The diviner doesn't just stop at 1 symbol. He uses a technique called recursive addition. He takes 2 symbols, adds them together using a fixed set of rules, and generates a third, completely new symbol. If you add an odd symbol to an even symbol, you get an odd result. If you add 2 evens, you get an even. This is exactly, and I mean exactly, how a modern digital circuit processes information. It's called modulus 2 arithmetic. The Bamana weren't just guessing the future. They were running a deterministic algorithm to calculate it. Now, the skeptics will say, okay, they had binary. But European geniuses invented the application of binary code. Let's talk about Gottfried Wilhelm Leibniz. He is often called the father of computer science because he invented the binary number system in Europe around the late 1600s. But where did Leibniz get his inspiration? History books often mention the I Ching from China, which is true. But there was another major influence floating around Europe at the time: geomancy. Geomancy was a divination system, popular in Europe, that used, you guessed it, binary figures made of single and double dots. Historians and mathematicians, including the renowned Dr. Ron Eglash, have traced the origins of this geomancy directly back to Islamic mystics, who in turn interacted deeply with the traditional knowledge systems of West Africa. The software running in the minds of European intellectuals had roots in African soil. But while Europe used binary for basic arithmetic, the Bamana used it for something much closer to modern computing: error correction. In modern computers, we use something called a parity check to make sure data isn't corrupted. It's a self-checking mechanism. The Bamana algorithm does the same thing. Because the system is recursive, the final symbol serves as a checksum for the entire calculation. If the final symbol doesn't match the mathematical rules of the previous symbols, the priest knows he made a mistake in the calculation. He wipes the sand and starts over. This is a digital error correction protocol, invented centuries before the first silicon chip was ever baked. If binary code was the only similarity, we might call it a coincidence. But the genius of Africa goes deeper. It scales up from the microchip to the motherboard. In the 1990s, mathematician Ron Eglash made a startling discovery. He flew over African villages and noticed something that European explorers had missed. The Europeans saw disorganized huts. Eglash saw fractal geometry. A fractal is a pattern that repeats itself at different scales. It's the same math used to generate computer graphics, design antennas, and model chaotic weather systems. Look at this village. The chief's house is a ring. Inside that ring are family enclosures, which are smaller rings. Inside, those are the altars, which are tiny rings. It is a perfect self-similar fractal. Today, when you play a video game and see a realistic mountain range, that mountain was built using fractal algorithms. The computer says, take this shape and repeat it at a smaller scale, over and over. The Africans didn't just stumble onto this, they engineered it. They used these algorithms in architecture, in braiding hair, in weaving textiles. They understood that to create stability and beauty, you need a system that feeds back into itself, a feedback loop. We often forget what computers are made of. Silicon, which is essentially sand. The Bamana priest moving his fingers through the dust was manipulating the same raw material that sits inside your laptop. He was organizing chaos into logic. Modern AI is based on deterministic chaos. It's about finding patterns in the noise. That is exactly what the African divination systems were designed to do. They were not magic tricks. They were information processing systems. They were early attempts to simulate the complexity of the universe using binary code. So, did ancient Africa invent the computer? They didn't build the hardware we use today, but they arguably wrote the first draft of the software. They understood the power of binary. They mastered the efficiency of fractals, and they codified it into culture so deep that it survived for millennia. History is written by the victors, and for a long time, the engineering genius of Africa was written out of the textbooks. But the math doesn't lie. The code is still there, in the sand, waiting to be read. If you want to see more forbidden engineering, click this video here, where we uncover the architectural secrets of the pyramids that modern engineers still can't replicate. And if you learned something new today, hit that subscribe button. We are just scratching the surface of the genius of Africa.